Okay, for 85, they've given us the sentence, or the two sentences. The sum of a number and its square is 90. They want us to find the number. So we're going to represent this with an algebraic equation and then solve for x to find out the number. Actually, this should say find the numbers because there are going to be two. All right. So the sum of a number and its square. We can represent that as, here is a number. Its square would be x squared, and they said the sum. So that means we would use a plus sign. So the sum of a number and its square is 90. All right. So here's the algebraic equation. We want to solve for x, and if you have exponent of 2, so far the only thing we've learned is the zero factor property. So that means I need this to equal 0. So I got to get rid of the 90. So we'll subtract 90 from each side. Okay. And let me rearrange this in descending order as I proceed. So x squared, we want that first. All right. And then plus x, that's positive. Minus 90 equals, that's a 0. Okay. And we're going to see if we can factor that. So if we can have something times something equals 0, we can use our zero factor property. Well, obviously it's going to be an x and an x, but we've got to figure out what goes there. We want a difference of positive 1, so we'll be looking at the factors of 90, and I might try to speed this process up a little bit. 1 times 90, that's going to take a while. 2, 3, 4, 5, 6, 7, 8, 9, 10. How about 9 times 10? That would give me 90. And for positive 1, I'll say positive 10, negative 9. Okay? So we have x minus 9 and x plus 10. We can take this, set it equal to 0, take that, set it equal to 0. Okay, I'm going to have to zoom out a little bit here. So if you have x minus 9 equals 0, or x plus 10 equals 0, get rid of your 9, plus 9, plus 9. So you get x equals 9. There's one possibility. Subtract 10, and you get x equals negative 10. So the numbers are 9, comma, negative 10. And notice if you plug them in, you'll get a true statement. Negative 10 plus negative 10 squared would be, that would have to go in parentheses, so that would be 100. If you subtract 10, you get 90. Okay, so that would work. And a 9, if you plug in a 9 plus, what's 9 times 9 is 81. 81 plus 9 is 90. So there's two answers to that. All right, a triangle 7 centimeters wider than it is tall. So for the height, they just have h. For the base, they have h plus 7. I need something underneath here. All right, they want us to find the width, which is the length of the base. So they're saying, how long is this base? All right, they give us the area is 225 square centimeters. So, and you remember the formula for area of a triangle? Area equals 1/2 base times height. Okay, they say the area is 225, and that's equal to 1/2 The base is h plus 7. And the height is h. So let's well, it's kind of tough to follow this exactly. If I send in the h, you're going to think I've gotten rid of parentheses, but I would also have to send in the 1/2, because this says 1/2 times each term, and this says h times each term. So I'm going to rewrite this, move down a little bit. I'm going to say 1/2 h times h plus 7 equals 225. Okay, and now I could send in my 1/2 h. This 1/2 is going to make things kind of complicated for factoring. We can do it, but we talked about clearing of fractions early in the semester, so let's go ahead and do that. Let's get rid of the 1/2. I'll move this up a little. Actually, I better zoom out a little. Okay. To clear it of 1/2, I would look for the LCD, which is 2. I multiply each side of the equation by a 2. The stuff inside parentheses is protected, so I just multiply this side by 2 and this side by 2. And 2 goes into 2 once, so all I'm left with is h, and then what's in parentheses, h plus 7. Equals, and then 2 times 225, that'll be 450. Okay, and you still can't solve for h, you're a good ways from it. You need to get rid of the parentheses, and we'll be subtracting 450 because we've done a lot of these with the zero factor property, and we're about to end up with h squared. So we have h squared plus 7h equals 450. Subtract 450 from each side. And you'll have h squared plus 7h minus 450 equals 0. And we want to factor this. 0, and we want a difference of positive 7. Alright, I'm going to try to use a shortcut because that's rather large. Slide this up yet again. Alright, so 450. I could list all the factors, but I'm going to try to speed it up and get right down to where there's just a difference of 7. So if I have 450 is 45 times 10, prime factorization would be 3 times 3 times 5. Prime factorization would be 2 times 5. So no matter what, I have to use up all of these. 9, that'd be, I'm trying different combinations that'll get me close to a 7. 10, 50, 10, 30, and 15, 25, 6 and 2 is 18, there it is. So if I grab this 5 and this 5, that'll give me 25, and that leaves the 2, the 3, and the 3. So 3 times 3 is 9, times 2 is 18, and it's a difference, and I want it positive, so it's positive 25, negative 18. Sorry, that's all off of there. So the factored form would be h minus 18 and h plus 25. And we have something times something is 0. So h minus 18 is equal to 0, or h plus 25 is equal to 0. Solve for h, you add 18 to each side, and you get h equals 18. Here, subtract 25 from each side, and you get h equals negative 25. And in our original, I can't fit it all on here, but in the original, height is a distance. So it can't be negative, it must be 18. So we take our 18 and plug it in, right where the h is. 18 and 7 is 25. So it's 25 centimeters long. So the distance from here to here is 25 centimeters. I will mention, if you had gone 450, if you had listed all the factors, somewhere along the line you'll get a negative 18 and a positive 25. I talked a little bit about using prime factorization to shortcut this process when you're having to deal with large numbers. So there are some other videos where I address dealing with large numbers in factoring.